Welcome to my IIT Foundation in Mathematics for 6th class students. Today's topic is solids. Generally, the square, rectangle, polygons, triangle, etc. are called two-dimensional figures. They have length, breadth, width, etc. measurements, and a circle and a point are said to be unidimensional. Now we will see these solids which have three dimensions: length, breadth, height, like that, three-dimensional figures. For example, duster, matchbox, ice cream cone, etc. are three-dimensional figures, solid figures. They have three dimensions. For example, this is a cube. It has three dimensions like length, breadth, height. But here for a cube, all the three measurements are equal. Length is equal to breadth is equal to height. Similarly, a cuboid, that is like this. A duster or matchbox is of the shape cuboid. It has length, breadth and height. So such solid figures are called solids. They have certain volume. They occupy certain space in the space. Therefore, that is called the volume. The space occupied by a solid figure is called the volume of that solid figure or a solid shape. So next we will see prisms. A prism. Two identical and congruent polygons parallel to each other form a prism. For example, we will take a triangle. This is a triangle. Two congruent triangles. So take another congruent triangle. And the vertices are joined. It forms a prism. This is a prism. So the bottom and the top are identical or congruent to each other. For example, we take another, this is a quadrilateral, and this is another congruent, equivalent or identical quadrilateral, and the vertices are joined, and this is a prism. Thus, two identical parallel polygons forms a prism. The vertices are joined. If the centers are joined by a line or line segment, that line segment is called the axis of the prism. And the length of this axis is called the height of the prism. And these prisms are named after the shape of their bottom or top. Both are congruent, identical and parallel to each other. So this is a triangular prism and this is the quadrilateral prism. Thus, a prism has two parallel polygons, identical polygons parallel to each other, and their vertices are joined. These sides or lateral surfaces are quadrilateral. The lateral surfaces of quadrilateral lateral surfaces are quadrilateral, and the bottom and the top are any polygon. So here the bottom and the top are triangles and the sides are rectangles or quadrilaterals. If the axis that is the line joining the midpoints of the top and the bottom is perpendicular to the base or top, that is called a right prism. Right prism. If the axis is perpendicular to the bottom, the prism is called a right prism. Then the prisms are named after the shape of their bottom. And suppose we take a triangle and the vertex, these corners are joined we find a prism. This is called a triangular prism. Triangular prism. Generally we take regular prisms, therefore the axis is perpendicular to the base or the top, and the length of this axis is called the height of the prism. H is the height of the prism, and this line is called the axis of the prism. So take any polygon. Take any polygon as a base, and the vertices are joined to a point in the air or in the space. This is a polygon, pentagon, 5 sides are there, and take a point in the air and joined all the vertices to that point. At that point is called the vertex of the pyramid. Vertex. This figure is called a pyramid, and this point is called the vertex. And if a line is joined the midpoint of the base and the vertex, that is called the axis of the prism, and the length of the axis is called the height of the pyramid. Axis of the pyramid, and the length of the axis is called the height of the pyramid. Height of the pyramid. If this is perpendicular, the axis is perpendicular to the base of the pyramid, then it is called a right pyramid. Generally it is called a pyramid. We consider only right pyramids. If this is oblique, not perpendicular to the base, like this is a quadrilateral, and the vertex is here. If we join the vertices like this, we get a pyramid here also, but this axis is not perpendicular to the base. It is oblique other than 90 degrees. Then it is called oblique pyramid. So generally we study about, or we consider only the right pyramids. Therefore they generally called pyramids. So from now onwards, pyramid means right pyramid only. The axis is perpendicular to the base. The base can be of any polygon. It is a triangle, rectangle, square, or pentagon, whatever it is. It can take any shape, any polygon. And the point O is in air, and it is joined to the vertices. Then the pyramid is formed. Now I will try to draw a hexagonal pyramid. This is a hexagonal, 6-sided figure. I will draw a hexagonal prism. Hexagonal prism. Suppose we want a hexagonal pyramid, it will be like this. Take a point and draw. This is a hexagonal pyramid. This is a pyramid, and this is a prism. So now we will consider some of the important points. Prism. This is a hexagonal prism. We can have triangular prisms, rectangular prisms, etc. So any prism have the number of lateral sides or total number of sides. Total number of sides is equal to number of sides of the bottom plus 2. Total number of sides is equal to number of sides of the bottom plus 2. Because here the number of sides are 6. Therefore, laterally there are 6 sides. Then bottom and top are 2. So number of sides plus 2. That is the total number of sides. Next, total number of vertices. Total number of vertices is equal to number of sides of the bottom into 2. Total number of vertices is equal to number of sides of the bottom into 2. Suppose the number of sides of this bottom are 6. Therefore, 6 vertices are there here. Again 6 vertices at the top. Therefore, number of sides into 2 is the total vertices of the prism. Next, total edges. Total edges of the prism is equal to number of sides of bottom, number of sides of the bottom, number of sides of the bottom into 3. Number of sides of the bottom into 3. See here, then there are 6 faces, 6 sides. Therefore, 6 edges were there. Again here 6 edges. Again the vertical edges are 6. Therefore, number of sides of the bottom into 3. That is the total number of edges of a prism. So now let us see how many sides were there for a prism, for a triangular prism. How many sides and how many vertices and how many edges were there. Consider a triangular prism. So let this prism we name it as A, B, C, D, E, F. So A, B, C, D, E, F, F, D, E. This is a prism. So number of sides or faces. Number of faces of the triangular prism is equal to number of sides of the bottom, number of sides of the bottom, plus 2. So it is triangular bottom, therefore 3 sides plus 2. So see, top and bottom are 2 and the lateral sides are 3, from parallel to 3 sides. So for a triangular prism there are altogether 5 faces. Next, number of vertices. Total number of vertices is equal to number of sides into 2. 3 into 2, 6. See, 1, 2, 3, 4, 5, 6. 6 vertices were there. Next, number of edges. Number of edges is equal to number of sides of the bottom, 3 into 3. 3 is 9. See, number of edges 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, 9 edges altogether for a triangular prism. Thus, the facts for a prism are number of surfaces, number of faces. Number of faces of a prism is equal to number of sides of the bottom plus 2. Number of vertices. Number of vertices of the prism is equal to number of sides into 2. Number of edges is equal to number of sides into 3. These are all true for any prism, whatever may be the shape of the bottom. These facts are true.